Disposable filtering facepiece particulate respirators, like these, are designed to filter particles out of the air. Different countries approve respirators to different standards. Depending on the certification or approval, a respirator filter might be tested and verified to filter anywhere from 80 to 99.97% of the particulate hazards from the air that passes through it. Filtering facepieces are tight-fitting respirators, meaning that they are designed to seal to the face. It is important that the wearer achieves a good seal when they put on the respirator. When properly fitted and worn, very little air goes around the edges of the respirator when the user inhales. Instead, almost all of the air goes through the filter. When the air travels through the filter, particles are filtered, and the air entering the respirator is cleaner than the air outside the respirator. It's important to note that masks such as surgical and procedure masks are not designed to seal to the face. They often have gaps at the sides, which means that more inhaled air will travel through gaps instead of through the mask. This is important because small particles can remain airborne for long periods of time. This is true for particulate air pollution, or PM2.5, factory dusts, and bioaerosols. Particles in the air may be inhaled through the nose and mouth. Someone wearing a mask will likely inhale more of the particles than someone wearing a well-fitted respirator, since air inhaled by a respirator wearer has gone through the filter. Respirator filters are made of a jumble of fibers which hold an electrostatic charge. When particles pass through the filter, they attach to the charge on the fibers. This capture happens a few different ways, depending on the size and charge of the particle. The largest particles are carried on air currents, collide with filter fibers, and then attach to them. The smallest, lightest particles move randomly through the air and inevitably encounter a filter fiber and stick. For filtration, it doesn't matter if the particle is a granule of silica, a hot speck of metal, or a biological particle, such as one containing bacteria, mold, or viruses. The filtering technology works the same way regardless of the type of particle. Once particles are captured on a filter fiber, it is very difficult for them to be released back into the air. The electrostatic charges on the filter fibers hold the particles tightly to the fibers, even if the particles are biological. Studies have shown that particles are not released from respirator filters during normal use. Whenever a person may be exposed to potentially harmful particles, including biological particles, a filtering facepiece respirator can help reduce their exposure if used and fitted correctly. If you have any questions about correct use, contact your local 3M representatives. You can find contact information on your country's 3M website.